Welcome to this detailed overview of decentralized cooling and heating systems from the ASHRAE handbook. These systems are designed for small to mid-sized installations, such as office buildings, hotels, apartments, and light commercial spaces, where independent control, simplicity, and lower initial cost are key. Unlike centralized systems, decentralized HVAC units are self-contained. Each unit includes its own refrigeration cycle, fan, filters, and controls, making them easy to install and maintain without major ductwork or piping. Decentralized cooling and heating systems are perfect for small to mid-sized buildings where you want simplicity, flexibility, and independent operation. Each unit comes factory assembled with everything it needs. You'll find these systems in many forms: window or through-the-wall units, air-cooled and water-cooled heat pumps, split systems, VRF systems, and packaged rooftop units. They're commonly used in offices, hotels, apartment buildings, and computer rooms, anywhere you need reliable, localized comfort control. Because every unit is tested at the factory, performance and quality are consistent before they even arrive on site. Modern versions also feature variable speed compressors and fans, which fine-tune temperature control while saving energy. And when using water source units, they can tie into a central plant's heat rejection system or boilers, providing an efficient and integrated solution for year-round comfort. Some major advantages include independent operation. Each zone functions separately, so one malfunction doesn't affect others. Lower installation cost and minimal mechanical room space. Pre-tested certified performance by manufacturers. Fast commissioning and easy scalability. Improved control for unoccupied zones, allowing energy savings during off hours. Flexible equipment options from multiple vendors. However, decentralized systems also have trade-offs. Temperature and humidity control are less precise than central systems. Economizers or advanced energy recovery may not be available on smaller units. Air distribution design can be limited by fan capacity or space. Maintenance can become repetitive due to many distributed units. Aesthetics and noise can be concerns if equipment is exposed near occupied areas. Despite these limitations, decentralized systems remain a practical solution for many projects where cost, schedule, and flexibility matter most. To improve efficiency, many decentralized units include economizers, systems that use outdoor conditions to reduce compressor energy use. An airside economizer introduces outdoor air directly into the HVAC unit when outdoor conditions are cool enough. This provides free cooling, reducing compressor runtime, and extending equipment life. Advantages include lower energy consumption, reduced tower and water usage, and improved indoor air quality through increased ventilation. However, they require careful control of humidity, proper drainage for condensate, and may increase system pressure drop. The water-side economizer achieves the same goal using chilled water from a cooling tower or evaporative system to pre-cool air. When outdoor wet bulb temperatures are low, this system can maintain supply air temperatures without mechanical cooling. Benefits include reduced compressor load, lower discharge pressure, and decreased energy use, but water treatment and blowdown increase operational costs. Next, let's talk about window-mounted and through-the-wall HVAC units, among the most common decentralized systems in residential and hospitality applications. They're compact, inexpensive, and easy to install, perfect for motels, dormitories, and small offices. A variant of these is the PTAC, or Package Terminal Air Conditioner, and the PTHP, which includes heat pump capability. Advantages: lowest first cost of any HVAC option, simple plug-in installation and quick service by replacement. Individual room temperature control, no ductwork required. Disadvantages: limited ventilation capability, higher noise levels due to proximity to occupied spaces, shorter lifespan, typically 10 to 15 years. Drainage and condensation management must be handled carefully to prevent water damage. A water source heat pump system uses a common water loop throughout the building. Each heat pump extracts or rejects heat to the shared loop, depending on whether it's heating or cooling its zone. This allows simultaneous heating and cooling in different areas, improving comfort and reducing waste. Advantages: excellent energy efficiency, especially when using geothermal or ground source loops. Compact and quiet operation. Simple installation for both vertical and horizontal configurations. Ideal for buildings with varying loads across zones. Disadvantages: requires central water treatment. Condensate drain systems must be designed carefully. Humidification and ventilation usually require separate systems. Multiple unit systems combine several self-contained units distributed through the building, each serving a specific zone or floor. They can be air or water-cooled and are commonly used in offices, apartments, and schools. Advantages include flexibility, modularity, and ease of servicing. Units can be relocated or replaced individually, reducing downtime. However, they require outdoor air access for ventilation and may occupy more mechanical space than centralized alternatives. Split systems are perhaps the most familiar type of decentralized HVAC system, separating indoor evaporator and air handler from the outdoor condenser. They are simple, low cost, and ideal for small commercial or residential buildings. Typical configurations include one outdoor condensing unit serving one or more indoor air handlers. Advantages: low initial cost and flexible installation. Minimal ductwork required. Tenant-level metering and easy service access. Disadvantages: multiple indoor units occupy space and require routine maintenance. Outdoor air economizers are rare. Condensate and refrigerant line lengths are limited by design. Commercial self-contained systems integrate refrigeration, air handling, and controls into a single vertical or horizontal package, often installed floor by floor in offices. They're efficient for buildings with variable occupancy and allow quick installation with minimal field labor. Outdoor packaged systems, better known as rooftop units or RTUs, are factory assembled and installed outdoors. They can range from 2 tons to over 200 tons of capacity. Advantages: simplified installation and reduced indoor equipment space. Easy access for service technicians. Factory testing ensures consistent performance. Disadvantages: exposure to weather increases corrosion and wear. Roof coordination, noise control, and maintenance safety are critical design concerns. Condensate must be properly drained to prevent damage. Rooftop units, or RTUs, are one of the most common HVAC solutions for medium to large commercial buildings. They're available in capacities from 2 tons to well over 200 tons, with both horizontal and vertical discharge options to suit different layouts. Because they're installed outdoors, RTUs save valuable indoor floor space and help reduce mechanical noise inside occupied areas. Each system is factory assembled and tested, ensuring consistent performance, faster installation, and better quality control. Of course, there are some challenges. Outdoor exposure means potential weather damage, corrosion, and maintenance safety concerns, especially in harsh climates. That's why proper design coordination is essential, from verifying roof load capacity and planning safe access routes to ensuring clear airflow paths. Designers must also account for weatherproofing, gas piping routes, and condensate drainage to prevent roof damage. And since RTUs sit directly above occupied spaces, vibration control and sound attenuation are key to maintaining comfort below. Finally, single-zone VAV systems regulate airflow to one zone, using variable fan speed control while maintaining constant air temperature. This allows precise control of load with minimal energy waste. Advantages: lower fan power consumption. Smooth modulation of airflow based on demand. Factory-assembled packages with advanced controls and BACnet integration. Disadvantages: limited humidity control capability. Outdoor installation exposure risks corrosion or weathering. Noise and vibration must be mitigated through acoustic design. Design considerations. Single-zone VAV systems follow similar design principles as commercial outdoor packaged systems, except they may need separate return supply duct openings and have no concerns about freezing in cold climates. Factory-installed economizers and BACnet integrated controls are often available for enhanced efficiency. Refrigeration and heating components are typically factory assembled, using air-cooled condensers for simplicity and reliability. Systems can use natural gas, propane, electricity, or hot, chilled water for heating and cooling depending on application. Proper sound and vibration isolation is necessary to reduce transmitted noise from compressors and fans to occupied areas. Outdoor noise mitigation may require acoustic insulation, duct silencers, or ceiling plenum treatments. Automatic controls and building management systems. Modern decentralized systems can integrate with building management systems, BMS, for centralized monitoring and energy optimization. Most packaged HVAC systems are factory-wired and pre-programmed, making them easy to integrate into existing building automation systems. Off-site computer monitoring or manufacturer-provided remote dashboards can enhance fault detection and preventive maintenance. Systems can include electronic or digital BAS controls for time scheduling, temperature reset, and load management. Coordination with ASHRAE Standard 135, BACnet, ensures interoperability among different control systems. Maintenance management. Decentralized systems are easier to maintain and require less technical expertise than centralized plants. Maintenance can often be handled by local service contractors instead of specialized technicians. Service contracts are common for multi-unit or packaged systems, especially in small to mid-size facilities. Because of their modular design, replacement and repair are localized, reducing system downtime. Building system. Commissioning. Commissioning ensures decentralized systems perform as designed, matching the specified comfort and energy goals. Should include factory checkout sheets, program logic, and operation lists for verification. Commissioning is essential during renovation or expansion to ensure system alignment with original design intent. Testing, adjusting, and balancing, TAB, helps optimize air and water flow for efficiency and occupant comfort. Commissioning should be a continuous process, with recommissioning done periodically or after system modifications. Proper documentation, TAB reports, as-built drawings, and performance logs, ensures sustainable long-term operation and supports warranty service. In summary, decentralized HVAC systems offer flexibility, modularity, and ease of installation, ideal for smaller or independently operated buildings. Thanks for watching.